Welcome everyone to my session. In this session, I'm going to talk about how we can employ API management practices for event-driven systems. So before we go any further, let me introduce myself first. I'm Sajid Ravindra. I'm a senior technical lead at WSO2. So at WSO2, my main area of work is on streaming integration technologies and API management. So when it comes to API management, I specifically look into how we can apply API management for streaming endpoints. So this talk is more on like sharing my experiences and my views with you all on this area. So before we get into the API management aspects, so let's briefly get ourselves ready with the event-driven system related concepts. So we all know in event-driven systems, applications talk to each other by publishing to topics and by listening to topics. So given a topic, it will have an address, it might publish data in some format such as JSON or XML or something else. And also the event itself will have a structure, it will have set of properties, or we call it fields. So these fields or properties can carry integers, strings, arrays, enumerations, or maybe a complex data type. So, and also when it comes to security, in order to connect to a certain topic, you might need to have valid credentials. And also a given topic might have set of access control lists attached to it. So the point that I'm trying to make here is that there are many details as an application developer you need to know before you can start connecting to a streaming endpoint and start developing your application. And also, you at some point you might also need to share such information with your colleagues or with your manager or with the admins or some other developers who are working on some other teams, right? So, and also another fact that we have to take into account is that these stakeholders, the system stakeholders, maybe can be within your same team, or else sometimes these stakeholders might be spreading across multiple teams. So it can be the case where there might be third parties who are interested about your system. So when your system grows, how can you facilitate these stakeholders to connect your system and collaborate effectively? So after some point, firing emails, giving phone calls, and maybe having a shared doc will not work anymore. So it requires for you to have a well-defined methodical approach, which uses well-defined industry standards and well-established processes so that everyone who are interested about the system and who are willing to who are looking into connected system can follow. So when I explain the problem and when I explain the problem statement, it might sound familiar to you, right? So one similar solution to solve such a problem is API management, which is used for REST API, right? So REST API management is something that we all know very well, right? It's basically a set of processes and practices that used to manage HTTP endpoints. So there are some key areas in REST API management. So one is discovery and documenting. So that's where you nurture your developer community. So you have your APIs listed along with their documentation, and sometimes you offer them SDKs that can be downloaded and boost up the development against that API. And lifecycle management. So given an API, it goes through several stages. So for an example, first the API will get created. So when it's ready to be tested, you can go ahead and deploy it. And then after some time, when that functionality is not required or relevant anymore, might need to replicate that. Depreciate that API. So likewise, there's a life cycle that is involved in API management. And the security aspects, we will need authentication and authorization. And analytics. Analytics is another very important aspect, so which lets you see through what is really happening on my APIs when it comes to in terms of the performance and in terms of its user interest, etc. So that gives you good insights and valuable insights about your API. The rate limiting is another very important factor where it lets you actually monetize your APIs. You can really make money out of your API by selling it. So, and another important factor is version. So when your API-based ecosystem matures, you will have multiple implementations for different versions of different backends. So therefore, proper versioning is something that is critical for a mature system. So these are some key areas. Of course, there are other areas as well. So regardless of the fact that now we are trying to manage endpoints that are in event-driven systems, these requirements will not change, right? Okay. So now we established that we are trying to solve a similar problem. So, but does it mean that we can use REST API management as is? As it turns out, the answer is no. So let me explain this in a little more detail later on. So before we go into the details, though, let's define what would be an API in an event-driven system, right? So we can think an API in an event-driven system as a logical collection of related topics or event streams. So this is analogous to a REST API where you have a collection of REST resources. So in this case, you have a set of related topics which are related topics, right? So anyone who needs to develop, so let's say a trading application, so he or she will only need to look into the real-time trading API, right? Which lists all the topics and their information related to the endpoint, the topics and the SDKs and the documentation, etc. So this is much more convenient in contrast to going and looking up through the list of topics that might be available in your event backbone, right? So, and also here what the API is actually it's a collection of topics. So the topic is something through which events flow, right? So event streams flow. So to account for that fact, so we'll call this API streaming API. So I'll be using that term from here onwards to refer to such APIs. Okay. So now, so this is now we established what is a streaming API is. So now let's briefly look into what are the key differences. So okay, if we compare the REST world and the streaming world, in the REST world you would invoke a resource in the API, but in the streaming world you would go and connect to a topic. And one of the key differences in REST and streaming world is in the REST world there's only one protocol, that is HTTP, right? But in streaming it can be HTTP based protocols such as WebSockets or SSC, or it can be Kafka, MQTT, AMQP, or something else. Also, so when it comes to the actions that you can perform on these topics and resources, so in REST world it's the HTTP word. You can do a get, post, or some other HTTP word. But in streaming world, it should be either publish or subscribe. And how you describe REST API. So Open API is a well-established standard in the REST world to describe an API. So similarly, async API is coming up as a well-established and well-adopted standard in the streaming world. So and then the message flow. So if you invoke a REST API, so what you would do is you would make a request and you would expect a response. But in the streaming world, what would happen is you might make a request, or you might just make the channel, and then subsequently you will start receiving events, right? So and then one of the most fundamental changes, I think that what causes these, that is the key difference out of all of these. So it's the communication model. So in REST world, it's synchronous, right? So when you make a request, your client is most of the time it's blocked until the response is received. But in the streaming world, you can't really do that, because once you make a request or once you make a channel, the response might come at any time, and there can be any number of responses. So these are the key differences that we see that we see between the REST world and the streaming world. So therefore, now we can get to the idea that okay, we can't apply REST API management as is, right? Okay. So, however, regardless of the fact that there are changes, some aspects in REST API management still can be used. I would say, or like we can adopt that fairly easily compared to others into the streaming world. right? So one such aspect is life cycle management. So here, development and DevOps processes, right, will not require any special changes due to the fact that you are developing a streaming application, right, or you are deploying artifacts into a stream event-driven system. So based on that fact, you don't require any special changes, right? So, and also when it comes to API discovery, so how you discover APIs by going into a developer portal and browsing through the available APIs and by looking at the documentation, etc. That experience also does not need to change because of the fact that the streaming API is a collection of topics, and whereas REST API is a collection of REST resources. And likewise, security. So as far as streaming API is concerned, we can still use the same security mechanisms such as OAuth, API key. The fact that this API is managing set of streaming endpoints does not demand a change how a client application is authenticated at the API level, right? So, and also we can inherit nice features such as fine-grained access control that is used in RESTful, such as OAuth scopes. So by using OAuth scopes, we can provide fine-grained access control role to topics, right? But I also have to tell that it's true that streaming backbones have their own authentication systems, custom authentication systems, but it's an API implementation detail. So it's similar to how you implement connecting or integrating with an HTTP endpoint which uses let's say a custom authentication mechanism, right? Okay. So now, so that's the good side of it. So now we know, okay, we can reuse, or we can adopt certain aspects of REST API management fairly easily into streaming API world. But also, as I pointed out before, there are differences, right? So now, let's see what are these differences, and let's see like what sort of changes that we should do in order to adopt better or realign these aspects into the streaming world better. So first, the API design experience, right? So in the world of event-driven systems, we naturally think in terms of topics and events and event streams, and then there you don't do gets and posts, or instead you go and subscribe to a topic, or you can publish to a topic, right? So the API design and API development experience. So this has to be in line with that. So if we use the REST jargon to build up a API design experience or API development experience for streaming world, that might not feel good. So it's just that we have to use proper jargon, and we have to use proper constructs in order to give, I would say, streaming native feeling to the API development, right? So if the developers and also the async API initiative. So async API initiative is something that is widely adopted and everyone tries to follow. So as part of your API design and development experience, it will be very beneficial to have async API support. So when I say async API support here, for an example, let's say you design your API and then you won't share it with someone else. So how would you do that? So you can very easily let your API development tool export your API as an async API definition, right? So now this is a well-known standard, so that maybe let's say another team who are residing on a let's say who are operating in another organization, they can get that async API definition and very easily use that API async API definition to plug into your system. So likewise, you also should have the facility to import async API definition, so that you can also plug into other systems quite easily by using a well-known standard. So here the point is like overall what I'm trying to point is like the API design experience shouldn't be something that is made out by squeezing in streaming related constructs into the REST world. Instead, it has to be different. It has to be different, and it has to be streaming native, I would say. right? And then one other important aspect is rate limiting and monetization. So in asynchronous communication, requests and response paths are decoupled, right? So the responses can come at any time, and there can be any number of responses. But in the REST world, it's not the case. It's much easier. The model is much simpler in REST world, where you make a request and then you get the response in a synchronous manner, right? So now, therefore, we need to do this metering and counting of events and requests, both on request and response path. But in the REST world, the number of requests, we can say like roughly number of requests are equal to the number of responses. So the counting requests is enough at REST world, but that's not the case with streaming. You have to do the metering on both parts. Also, the business plans, like the business plans that you offer on top of your APIs, they have to be different from REST ones. Where I mean, REST ones are mostly based on the number of requests. For an example, okay, if you want to make 50,000 requests per hour, you have to pay this much. Like you see such business plans, right? But in the streaming world, that model won't work. So we have to divert from that. So as I said earlier, in streaming APIs, a given request can have many responses, or maybe we may call it updates or events, right? So hence, the rate limiting has to be applied, and the clients has to be charged based on the number of updates it can receive, isn't it? So if you are going and connecting, let's say you are building a real-time stock trading app, right? So you should be charged for how many updates that you can receive from the trading system, so that your application have up-to-date information, as well as more real-time and rich experience. And also another way that you can develop business plans for streaming APIs is like based on the number of subscriptions or the number of persistent connections that you can make simultaneously. Right. So this is one of the key resource factors. For an example, let's say if your API, the gateway that is hosting your streaming API allowed to maintain 100 persistent connections at a given time. So it will take a certain amount of requests, a certain amount of resources. So if it's 1,000, so it will be more. So likewise, so the API provider has to incur more resources as it provides to as it lets the API consumer maintain more persistent connections, right? And also another very important fact, another key differentiator when it comes to streaming APIs is that the event stream consumers can actually expect different level of consistencies when it comes to message delivery, right? So let me explain this a little bit more. So some updates or some events you can afford to lose. They might be simply updates to the state. So for an example, okay, you let's say you are looking at a stock market index, right? So if you lose one event in middle which carries this information, so the worst that happens is that you might have an older picture, or you might have a older state, right? But it doesn't show you a wrong information, of course. But of course, there's a tolerate level of toleration that you can do, how old it can be. But however, it can be very easily recovered, right? So in that case, you might be, I mean, if these events are carrying just status updates, it might be okay for you to lose some events here and there, right? But also there might be the case that this event stream might be carrying incremental updates. For an example, let's say it's telling you what are the changes happening to an order book that is in the trading system. So for an example, it might say, okay, now add order, now delete, now modify it. Likewise, it tells you the incremental changes that are happening. So what will happen if one of those changes get dropped? So of course, now you end up with an inconsistent state. So therefore, so business plans that silently drop events in middle won't work there. So in such cases, we have to have business plans which doesn't do that, right? So when the quota is exceeded, you drop the connection and the client is notified. So the client clearly knows I was dropped at this point, so he can take the required action to recover, right? And also another important aspect is like you should have a mechanism to let the clients protect themselves. For an example, let's say you have developed an application which can only consume 10 events per second. But what will happen if you push 100 events per second to that client? So of course it will crash. So there has to be mechanisms which let the client say, okay, I don't want more than 10 events per second. So these are some things that you need to think about when it comes to rate limiting and monetization in the streaming API world. And then analytics. So, and again, due to the fact that the communicate due to the fact that the communication in streaming APIs is asynchronous compared to the synchronous communication of RESTful. So we have to we have to redefine and realign certain how you define certain metrics and how you calculate certain numbers, etc., right? So for an example, let's say like how do we define what API usage means? So in the RESTful, it's quite simple. It's a number of requests. But in the streaming world, can we say so? Like I mean, it's actually an open question. So can we say it's the number of requests, or is it the number of subscriptions that were made, or it is the number of events that had flown through so far? Right. So therefore, we need to define. We might need to redefine certain matrices, and also some matrices might be not relevant. For an example, let's say, I mean, what would latency mean in this asynchronous mode of communication? So, I mean, can we measure it, or is it applicable after all? So, likewise, the analytics aspect also has to be fine tuned to give uh, a clear view on clear view on the usage of the streaming API and how the users had interacted with them, and how many events have flown through and how was it performing, etc. So it's just that the point that I'm trying to making is that you still need this information, but the way that you calculate will have to change, and some matrices might need to be redefined, and some matrices might not be relevant, and also we might need to bring in new matrices such as, let's say, the number of persistent connections that is there. Likewise, so there are a set of things that you need to rethink when it comes to analytics as well. So this is a simple reference architecture that you can use to implement such streaming API implementation, right? So I'll not go into a lot of details here. So here the simple idea is like let's say you can actually place an API gateway fronting your eventing backbone, just like you do with the REST endpoint. So they are by using these gateways, you can enforce QoS, apply security, etc. So, but one fact that we have to realize is that most of these gateway that is out there currently, developed by various vendors, are actually supporting only HTTP based protocols, right? But it's natural, right? So there's nothing wrong in that, because they are developed to handle HTTP endpoints. So, but I mean, most of the messaging layers does not support HTTP based. HTTP based protocols, right? So therefore, so you might wondering, okay, what can you do then, right? So what I would say is like, still I think the API management can be used in such contexts as well. For an example, you can exclude the functionalities where you apply QoS and security, but instead still you can use API management for discovery, lifecycle management, documenting, versioning, etc. So that is still there. So there you don't intercept the message, but instead you provide a view as to, okay, what is being deployed in my eventing backbone, as more of a advertiser, right? And also alternatively, one other thing you can do is you can use a simple integration component which will convert you. For an example, let's say there's this client application who needs to consume events that are flowing through a Kafka topic. So what could you do? So you can just simply have a small microservice or a small purpose-built integration component which will do that conversion for you. So that and then you can expose such endpoints as streaming APIs to the external clients. Okay, so that's all I wanted to talk about. So now let's get into a demo. So let me do a brief demo of the concepts that I have just explained. For this demo, I'm using this particular project that WSO2 and Solas are working in collaboration. This is to build a pilot solution that will bring in API management capabilities to Solas platform using WSO2 API Manager. I'm taking this implementation or this pilot implementation as a concrete example to walk you through the developer experience part, especially of creating and designing a streaming APIs for an event-driven systems. So let's start. So now currently what you're looking at is actually WSO2 API Manager's publisher portal. So here from Solas event portal, you can design your eventing applications, and then export it as a async API definition. So once you do that, you can import that to the WSO2 API Manager. So as I explained before, we call it a streaming API to account for the fact that we are managing event streams here. So now here you can simply import such async APIs definitions that was exported using the event portal of Solas platform. So I have already downloaded such API definition. So let me import that. Okay. Yeah. So this is my YAML. Yeah. So it says, okay, it's has identified it as a Solas event portal API. So let's create next. So I'll give it a good name. Solas maintenance API. Okay, and I'll give it a context. Solas. So this is for the for the bookkeeping inside WSO2 API Manager. So let me create the API. So now you get to this view. So now especially if you go and look at the topics page, so now you can see, so the topics that is being published by the Solas application is being imported into WSO2 API Manager. Now what we're trying to do is we are putting these topics together and creating an API out of them. So here you can add descriptions, if you want to add certain descriptions. And also you can you have a very user-friendly view, and also developer experience that gives you that, okay, now I'm working on a API that is related to an event-driven system. And also if you can go and see the async API definition itself if you want. Likewise. So once you're happy with editing and all, what you can do is you can go and deploy this API. So here we have only one broker setup. So what I'm doing here is I'm going to deploy this. So once you deploy that, so let's go to the deployment page. So now it's been deployed. So here you can see, okay, you can access this API through these endpoints via these protocols. And then if you go to the overview, so now from the API developer's perspective, you have done the design of your application at the Solas event portal, and you have exported it out as an API. Now in the WSO2 API Manager, you are creating an API to expose your event portal in a managed manner. And then when you come to this state, now you can publish this. So now from the API developer's perspective, you have publishing an API which exposes the maintenance event application. So now let's go to the developer portal. So this is where the actual the applications who are looking to consume this API will have to come to. So here you can see, okay, we have something called Solas maintenance API, and it has these two endpoints exposed by it. And also, if you need to see more information, you can go to the wave definition, and it will give you, okay, these are the channels that are out there, and it has all the information about the payload, etc., with some example payloads. So now you have so the application developers can very easily discover all the information, not just that the API and the endpoints are there, but also what other information such as the event types and example payloads, etc. So this way, now it's a very convenient way of discovering what could have been just raw set of topics. So now we have the API. So what if you want to access the API now? Because now we are making this accessible in a managed way, so you have to subscribe to it. So for that, you have to create an application. So I'll use the default application here. Sorry. Yeah. Okay. Yeah, I'll create an application. I'll create, okay, my concept. I'll skip this information for time being because we are running out of time. So here we can go and subscribe to an API. So here I'm subscribing to Solas maintenance API and I'm subscribing. Right. So once the subscription is successful, what you can do is you can simply go and generate the keys that is required to access the API, and then embed these keys to the subsequent calls to the to these endpoints. Yeah. So I hope this gives you a very of course, it's a short demo, but at least a high-level idea as to what is a managed eventing API or a streaming API, and how its developer experience can be. Yeah. Okay. So yeah, that's all I want to do show in this short demo. So thank you very much for joining in. Yeah, thanks.